Thank you. It's so great to be here. So this is ClojureScript, Good Ideas Never Die. My name is Antonio. I work at a tiny startup in California called Ladder. We're building a fully automated life insurance product to help cover American families for life insurance. I also do a lot of work on the ClojureScript compiler, and I've recently created a project called Lumo that I'm going to be talking a little bit about today as well. So this talk is a little bit similar to the talk I gave last October at the Conch, and it expresses some very powerful features of ClojureScript as of today, along with what you can use it for, and maybe what I can expect it to be a little bit further down the road. But before we get into the talk itself, I think it's always helpful to kind of take a step back and understand why we're doing this at all, and why ClojureScript ever came to be and what its aims are. So what is the grand vision or the bigger picture for ClojureScript ever existing or having ever been done? And the answer is reach. It's always been about reaching platforms where the JVM cannot go, about using an arguably better, more powerful language than JavaScript itself to program the web and other platforms. And I think we're in a pretty good place. And I would argue that we're kind of leapfrogging ahead of some well-established practices in the JavaScript ecosystem. So for the people in the room that have never used ClojureScript or don't know what it is, ClojureScript is basically the same language as Clojure, but it targets JavaScript platforms. So it runs on the browser, it runs in Node.js, it runs in React Native, and Electron. The next version will support web workers as well. It has the same persistent data structures, and basically it's at feature parity with Clojure on the JVM, except the concurrency model, because JavaScript platforms are and have always been single-threaded, so we don't really have concurrent programming in ClojureScript. So this talk is as of ClojureScript 1.9.946. This is the latest released version. And just a side note is when I mention Clojure or Google Clojure or the Clojure compiler, I'm not talking about Clojure the language. This is an unfortunate choice of name, I guess. So when I'm talking about Clojure compiler, this is the Google project that is a whole program JavaScript optimizer and compiler, which happens to be written in Java, so we can use it in the ClojureScript compiler, which itself is written in Clojure, to kind of apply all these sophisticated optimizations to our ClojureScript programs. So I'm going to run through a little bit some of the features that have been introduced to the ClojureScript in the past couple of years. And the first one is, it came out of a Google Summer of Code project done by Maria Galler, which was about having the Google Clojure compiler understand what foreign JavaScript you're consuming. And I'm going to go into a little bit of detail on this. So in ClojureScript, we like writing our namespaces just like we do in Clojure. And whenever we run the ClojureScript compiler through them, they're compiled into this Google Clojure module format. And the Google Clojure compiler needs to be aware of all the kind of namespaces in your project, what the dependency graph is, in order to perform this whole program optimization. However, foreign JavaScript written by other people in JavaScript ecosystem, they can be CommonJS, which is a different module format. It can be ES6 or ES 2017, or this new, always evolving spec for the JavaScript language, or they may be AMD. Anyway, there's a bunch of different module formats out there, and the Google Clojure compiler, thankfully, in 2015, introduced the ability to compile all these different JavaScript module formats into its own Google Clojure module format. And so the ClojureScript compiler kind of just took advantage of that. So the solution for consuming these external JavaScript foreign libraries to the Clojure compiler is just take them, convert them to the format that Google Clojure understands, and have it be part of our ClojureScript projects. 2015 was also when initial code splitting support was introduced in the ClojureScript compiler, and I'm going to talk today a little bit later about how in 2017 we kind of revamped this module support and made it much better. Well, I think something that is most close to me is the introduction of an optionally self-hosted ClojureScript compiler in 2015, and this is a really cool kind of feature, like having the ability to optionally run ClojureScript in ClojureScript. So the way it works is the ClojureScript compiler is mostly made of two large parts. One is the analyzer that takes all these different S expressions and turns them into an AST. And then there's the compiler itself that takes this AST and outputs JavaScript. And the way self-hosted was done was basically point ClojureScript at its own sources, the sources for the analyzer and the compiler, and now we have the ability to ship the ClojureScript compiler to the JavaScript platforms and have ClojureScript compile itself and compile ClojureScript programs in JavaScript platforms. So this is a really cool feature, but the reason why it was made is not really about being cool. It's not about scoring cool points or anything. It was necessary, and it is still necessary today, because in some cases we want to, my first slide was talking about reach and how we want to reach all these different platforms. And there are still places where the JVM cannot go, and the ClojureScript compiler is written in Clojure, which needs a JVM to compile. So this was about extending ClojureScript's reach even further to places where the JVM really can't go or people don't want it to go. And so a personal product of this optionally self-hosted compiler is Lumo that I developed in late 2016. And what it is a ClojureScript, a self-hosted cross-platform ClojureScript environment that runs on Node.js and the V8 engine. And it's basically a REPL that starts really, really fast and lets you run ClojureScript forms and consume built-in Node modules and reach to the NPM ecosystem if you ever need other foreign JavaScript. And something that also came from Lumo at the beginning of 2017 was the added ability to compile whole projects without the JVM. So when I speak about compiling whole projects without the JVM, is basically the self-hosted compiler could already compile ClojureScript in ClojureScript. However, it didn't have all the stuff that was necessary to kind of shuffle dependency order around, apply Google Clojure optimizations, all the things that the ClojureScript compiler on the JVM does was not yet in the kind of non-JVM ecosystem. And I think Lumo might have been the first entirely self-hosted ClojureScript compiler for ClojureScript projects without the JVM, and I'm really excited about it. So kind of going back to the features that we introduced in ClojureScript in 2016, and 2016 was kind of the year where the focus was mostly about closing the gap of the differences that ClojureScript had with Clojure, and one of those was what we call the Clojure to ClojureScript namespace aliasing. And the reason why this was needed was, say we have the Clojure.test namespace. It has a bunch of macros and it's written in Clojure, as we all know, and we all use it. But in ClojureScript, because ClojureScript macros are written in Clojure, we needed a macros namespace for Clojure.test. However, that namespace was already taken by the Clojure namespace, which means we gotta get a different name for this, and it happened to be cljs.test. this happens with every namespace that in ClojureScript that basically needs macros. CLJS core async is one other example. CLJS spec is another example. And so Clojure to CLJS namespace aliasing is basically about having the ClojureScript compiler know that when you write clojure.test, for example, you're really requiring CLJS.test, and it knows that information and just makes it work seamlessly for you. On the same theme, we also made implicit macro inference work in the refer form, exactly because of the same reason that macros in ClojureScript need to be written in Clojure. There was this special keyword, refer macros, introduced since the beginning of it. However, in 2016, we made it work such that we can implicitly infer that you're requiring a macro or referring to a macro. And so we kind of made the refer macros keyword deprecated, I guess. But what's really interesting now is that putting the previous slide and this one together, you can see the last line over there on the slide. You can basically require Clojure tests and refer to its macros as if you're writing Clojure, which eliminates the need for reader conditionals if you're now writing CLJC files, as many of us are. There were even more enhancements in 2016 in the compiler, and the theme was always the same thing about kind of closing this feature gap. So we made require and refer Clojure and import optional work outside of the NS form. There was this implicit assumption in the ClojureScript compiler that you always had to have an NS form, and this kind of hindered the progress in some sense, because we can have data readers because the compiler would expect an NS form to be there. It wouldn't allow scripting without an NS form. And what this actually meant is we can now make all those use cases work, and with the added benefit of having deleted a bunch of REPL code that was just there for getting around this. We also improved the quality of the project itself a little bit. We made it so that ClojureScript runs on CI now. We have Windows and Linux CIs running for the ClojureScript project. It runs on every commit. I obviously chose a screenshot that makes this look really good, but there aren't green ticks all the time, and it's really been useful to catch a couple mistakes or oversights that bugs that never made a release because we caught them early and often. So the year of 2017 started off with support for yet another cool feature, which is extrinsic inference. Extrinsic inference is, again, and so I mentioned that the year 2016 was about closing the feature gap between Clojure and ClojureScript. I would say that 2017 was about having Clojure not be its own island, having ClojureScript not be its own island, and kind of reaching towards the wider and the bigger JavaScript ecosystem that is out there, and not have all those libraries and all that code be foreign to ClojureScript. And the segue to externs here is, because the Google Clojure compiler is this whole program optimizer and compiler, it needs to know everything ahead of time in order to optimize your whole program. So if you're, and one of the optimization passes that it does is it will rename variables and property accesses in your compiled to JavaScript code. So externs are a way of telling the Google Clojure compiler that, hey, here's this JavaScript variable that I'm accessing. Please do not rename this one because you are not aware of it. I'm concatenating this foreign JavaScript onto your finished product. So please don't rename this one or my code will not work. And externs, until until this feature was always manual labor and kind of a pain to accomplish. But with extrinsic inference and some added hints, kind of like type hints in Clojure code, you can now have the ClojureScript compiler output a file that has the extrinsic for you without you not needing to do any additional work. So if you just set the infer extrinsic option to true in the compiler, it is disabled by default because of you need to opt in because of all the dependencies there are in projects. And then there's this namespace local variable warn on infer, which you want to set to true if you want to get warnings about externs that are not recognized in your namespaces. So in this case, I have a function called interop code that takes a variable called x as an argument, and I'm using interop notation to call a method foo on x. However, the compiler cannot infer what x is, which is why we need to put a kind of a type hint there. And so we're saying, whenever I call foo on x, x really is a JavaScript object that has a foo method. And so the ClojureScript compiler will now not issue a warning, and it will automatically create an inferred externs.js file with the appropriate externs for the code that you're calling. And the only thing that you had to do was put a little type hint there. This doesn't come without caveats, of course. And so it's kind of in alpha status still. So do expect to be on the bleeding edge, but we do encourage you to try this out and report back. In some cases, you still need handwritten externs, and one of those cases is when you have like a function that returns a JavaScript foreign function that returns an instance. And the Google Clojure compiler asks that you add javadoc, or JSdoc, I guess, for every JavaScript function that returns an instance. So in these cases, you still gotta mess with written externs, even only if to add that little JSdoc declaration saying this is a function that returns an instance. This can be called with the new keyword. However, extrinsic inference can still help you here because you can generate the kind of the bare bones externs, the skeleton of what they will become, and then just add the JSdoc annotation, and take advantage of the generated externs. So let's talk about code splitting. I mentioned that we had initial support for code splitting in 2015. Then in 2017, we kind of revamped and made it much better. So code splitting is discussed extensively nowadays in the world of browser applications in order to improve parse times, compile time, render, and time to interactive metrics in kind of single page apps that need to run on slow networks, low-end devices. And there was a really great talk last year at Clojure West by Peter Shook, and he gave a very cool talk about some topics in ClojureScript that I really encourage you to go and watch if you haven't. And one of the topics that he mentioned was code splitting, and he demonstrates how all the manual labor that was required to code split a ClojureScript application, and this was a little bit too cumbersome at the time. So we kind of, in 2017, we kind of went ahead and made that part of his talk completely obsolete by changing how code splitting works in the compiler for the better. As a side note, ClojureScript has also gained a blog in 2017, so you can go to clojurescript.org and click on the news section, and you'll have some useful posts of all these new features that we added. They're still up to date, and you can learn about all the things that I'm speaking about today by reading these blog posts. Without further ado, though, how does this enhanced code splitting works now in the ClojureScript compiler? So previously, and this is the new version. I did not include the way things work because I don't want to induce anybody in a bad way of doing things. So the way it works is you kind of specify they're usually called chunks. we call them modules because really they are Google Clojure modules. But you basically define which chunks you wanna have in your application. So in this case, your app has a public and private parts that are split. Because you wanna say render your public page to users without having to load all the code that only signed in users will ever see. So the way to do this is declare these two chunks, public and private, and then say, please output this one to this JavaScript file, output the other one to another file, and then specify what are the entry points for those kind of split points. And the ClojureScript compiler will take this information, and given all the namespaces that you have in your project, in your class path, it will figure out what your module graph is. It will compute automatically what things go to what split points. So just by specifying the entry points, you can just recursively find all the namespaces that belong to each one. And this is something that, and this is where the enhancements really come. This is where we greatly enhance this feature, because previously you have to, I mean, it was much dumber, and you kind of had to specify all the entries one by one of which things you wanted in which modules. And just by simply coming up with, or automatically computing the module graph, we gained a bunch of other cool consequences, really. And one of them is, say you want to have a vendor bundle, right? You still have a public and private chunks, but now you're saying there's also this vendor bundle, and the example I put here is reagent, which is a common React.js wrapper for ClojureScript. And so you're saying, now I have this vendor bundle, please find all the things that, compute all the things that you can find from the reagent namespace. This is the entry point. Please find all the things that it depends on, put that in a separate bundle, and now if you load a home page, you will also need to load this vendor bundle because both modules depend on it. But now whenever a user signs in, for example, you're not going to have to load any additional code because all this vendor code that is common to both of them is already loaded. I want to show you one more cool trick that I didn't see at first, which is having a completely different chunk that has an empty set of entries. And what this allows you to do is, if you have, say, a home page and about page, and both depend on this chunk that is empty, what the compiler will compute for you is, it will pull common code up in the module graph, and now all the code that is shared between, say, a home page and an about page is now in this common chunk that you will not need to load whenever you load one or the other, provided that one of them is already loaded. This was kind of mind-blowing for me, that something that I didn't know at first. So we talked about code splitting, but how do you actually load modules? And the way you do this is we created, again, in 2017, two new things. One of them is this cljs.loader namespace. The other one is a macro called resolve. And this really is this is all the code that you need to wire up code splitting and loading in a ClojureScript app today. The loader namespace has a load function that takes a keyword, which is let me go back here. So the same keyword that you defined in the compiler options at the about page is the one that we're loading on that line below the NS declaration. And you pass it a callback, say, please, Google Clojure, when you're finished loading this chunk, please call this function. And what we're doing here is, at runtime, we're going to be resolving the render function in the about page, and we're going to call that function. And the reason why this resolve macro is needed is, I mean, I could just require the about page in my namespace declaration. However, that would make it so that the about chunk would be empty, right? Because the homepage chunk would be able to find the about page through the dependency kind of crawl. And so we know that at that time, this module has been loaded, so we resolve it and we call that function. This way, both modules have code in it. None of them is empty. And then at the end, it's just you got to set the current chunk as loaded. All this is in this Clojure the Definitive Guide, a book by O'Reilly that I encourage you to read. It's been written in, I think, 2011, but it's surprisingly still up to date. Just doesn't include the latest JavaScript module processing stuff. Which leads us to talk about JavaScript. This is a picture from a blog post that came out a couple of years ago, which with the title JavaScript Fatigue. And this, we all know that in the JavaScript ecosystem, I mean, it's a huge, probably the biggest programming language ecosystem to date. It has lots of JavaScript developers putting out a lot of libraries, putting out a lot of tools. And as a compiled to JavaScript language, we don't want to be stuck. We don't want to be isolated in our own lonely ClojureScript island. We need, and in some cases we really, or we want, and in some cases we really need to interact with these JavaScript libraries and frameworks such as React.js or some others. And this was also what we did last year. And we really did a lot. And okay, the picture is cut because I had to tweak my slides to 4:3. So, but what this picture is meant to show is there are three kind of spikes in the ClojureScript's activity history. There was a spike in the initial release. There was one when self-hosted came to be, and there was one that in the middle of 2017 that is the last one that is not shown there, where we really did a lot of work. There was like a huge spike of activity, and so we made it so that consuming and integrating with foreign JavaScript is now much easier. So kind of piggybacking on the work that Maria Geller did in 2015 in the Google Summer of Code project and other enhancements to the Google Clojure compiler, we can now just take arbitrary NPM modules, run them through the Google Clojure compiler, and use them seamlessly in our ClojureScript namespaces as if they were regular ClojureScript namespaces. You can use as, you can use refer, you can use namespace without needing to have, mostly without needing to have interop code. And this is, I think, really exciting. So before, the way you do this was just bundle everything together, consume foreign code through the foreign libraries key in the compiler options. And then once you're finished running your ClojureScript through the Google Clojure compiler, you prepend that foreign JavaScript to your bundle. And you need a lot of externs for this. And there still is a community-driven effort, CLJS SJS, that works this way. They're basically a project that aims to package a huge number of JavaScript libraries along with their externs so that you can consume them through Clojars. Or if you wanted to consume JavaScript modules, you have to do manual labor, such as in this piece of code where you'd say, so here's a JavaScript file that I have. It provides this namespace, and it is a it is this kind of module type. And you'd have to do this for all the single JavaScript files that you wanted to run through Google Clojure. And there was no reliable way to know if they were going to work. And so really the goals that we had for a modern interop story between ClojureScript and JavaScript was really, I want to consume NPM modules. I want to consume them in a way that mostly I do not need actions. I want to consume them in a way that Google Clojure will understand them in order to kind of apply sophisticated optimizations such as that code elimination to those foreign JavaScript sources. I want to integrate ClojureScript code in JavaScript projects, say projects that have JSX or that use Babel or stuff like that. And this is a concrete use case that we heard at Euroclojure 2016, where the CTO of a company came to us and said, hey, my designers are really comfortable with React and JSX, but they never could get into Hiccup, which is the Clojure kind of DSL that Reagent and also RUM uses. And so at that time, there was no clear story of having their designers write JSX and be able to consume that in their ClojureScript namespaces, and then have all that go through Google Clojure. What they did was they pre-processed their JSX, they output a giant bundle that was consumed as a foreign dependency by ClojureScript, which means for every code that the designers wrote, they would have to write externs and all that. And so I think we really delivered on making that concrete use case work last year, and that is very exciting, I think. So I'm going to run through, kind of answer all the goals that we had. And so how do I consume NPM modules is I add a key called npm depths with the libraries and versions that I want to have in my ClojureScript project. This is also optional. If you have another way of installing those NPM dependencies, ClojureScript will know they're there, so you can just require them in your project. But this is a way of telling the ClojureScript compiler, like, please, when you're compiling my ClojureScript, please install those dependencies so I don't have to keep a package JSON or something like that. And so if you see in the example on the below, you can just, I'm requiring React, and I'm requiring React DOM, and I'm requiring them in a way that resembles any other ClojureScript namespace, or any other Clojure namespace for that matter. And so I can just create element, and we know how to emit JavaScript code that is really a JavaScript interop property access for the React object. Because now Clojure, we know that Google Clojure has transformed these modules that we're including and is now aware of it. So the holistic, the whole program approach that it uses can now work with all these foreign dependencies. We also made string requires work, because this is a very common use case in JavaScript, in the JavaScript land, is requiring modules with slashes in them, and the symbol spec in Clojure really does not work with these cases, especially when they're arbitrarily nested paths. So this use case also works. We relax that constraint. And we also added the ability to resolve, and this might seem a little weird, but resolve required modules as variables. So there's this common pattern in the JavaScript ecosystem where your module just exports a single function. But that has no true equivalence to ClojureScript or Clojure namespaces, because namespaces always map to kind of an object with some properties in them. So now if you require, in this case, if you require my module, you can then use that my module as a variable, because that really is a function. There's no other way to access it otherwise. So integrating with JavaScript sources, like if you have subdirectory in your project that is, say, a JavaScript, a bunch of JavaScript modules, or even JSX, as I mentioned the use case earlier, you can just include that as a foreign library. Say, this provides this namespace, and then just require that in your namespace declaration. And there's this now additional keyword called preprocess, and this is where the kind of the magic happens for preprocessing stuff with say JSX with Babel. Is you pass it a symbol that the ClojureScript compiler is going to resolve at runtime, and before emitting or before even passing the Google Clojure compiler that module, it will say, okay, so I have this JSX. I will call this function on this code that I have, and I'm expecting to get back something that I can feed into Google Clojure. And this really is extensible in userland, because now you can use Nashorn to convert JSX to JavaScript, or you can shell out to Node.js, or you can do whatever you want as long as you pass valid JavaScript to, or as long as your preprocess function returns valid JavaScript that can be fed into Google Clojure. I'm also proud to say that we did all this without any breakage whatsoever. So there's a clear upgrade path from this kind of, I call it prehistoric in the slides, way of including foreign libraries to the established way of consuming NPM modules, and is an additional global exports keyword. And what this is telling you is, so previously I was consuming a foreign library that had this global variable React. So I can still do that. And so when I require React in my namespace, as I'm doing now, and I use it with refer or as, and use the normal alias access that we are all used to in Clojure, the ClojureScript compiler will know that this is still an old thing, that it needs to map to the old format. And so there's a clear upgrade path here for library authors to kind of phase out the old way of doing things, but using the new syntax. So they can start converting today, and they will still work with old code. So the final part of this talk is, I propose to answer the question at the beginning of what can ClojureScript do for you today? And I will say there are a bunch of different things that ClojureScript can do for you today. There are several React wrapper libraries that you can use that work really well. Some of them in the beginning of React.js were even faster than React.js itself because of ClojureScript's persistent data structures. So kind of all the algorithm for diffing React trees was faster in ClojureScript than it was in JavaScript, simply because of the immutable model and the persistent data structures. We now have wider JavaScript ecosystem integration with your favorite package manager, be it NPM, Yarn, whatever comes tomorrow. As long as there's code in node_modules, we know how to process that. We can do code splitting, advanced code splitting with first-class chunks or modules, as I mentioned, and cross-module code motion, which I'm still to see in the JavaScript ecosystem. So cross-module code motion means if you have two different modules, and both use a common namespace, but one of them never uses a function, we can allocate or really Google Clojure can allocate part of that namespace to one chunk and the other part of that namespace to the other chunk, such that all those variables are local and don't need to be loaded when you're accessing them or calling them. We can now target the web, as we always could since the beginning, Node.js, React Native, web workers. We can use the optional self-hosted compiler to bring ClojureScript to places where the JVM can go. So you can compile all these ClojureScript projects without JVM at all if you need to. Another very cool use case of the self-hosted compiler that I'm yet to see is, say you have an Electron app or a React Native app on iOS or Android that you want to ship code updates to. So you can ship ClojureScript code updates to and have your app compile the code update on the fly and do kind of over-the-air updates in your app without needing to push a new version that needs to be reviewed or through all those kind of app stores or package managers. So I don't know. I think we're still at the beginning of what ClojureScript could be. Lisp is 6 years old, and we're still using it today. I think we'll continue using it too. I think great ideas never die. There's one more thing. I mentioned in the beginning that Clojure's concurrency model is kind of the only thing missing from ClojureScript to kind of be at feature parity with Clojure. I'm really excited about a proposal that came last summer from the WebKit team, proposing how concurrent JavaScript, multi-threaded JavaScript could work with shared memory concurrency. And I'm really excited for this proposal, and I really hope it comes to be something. Because I think ClojureScript is uniquely positioned, like given a support from the platform, I think ClojureScript is uniquely positioned to be the best concurrency story in the JavaScript or compile to JavaScript ecosystem out there. I really hope this happens. That's all I have. Thank you.
Questions, anyone?
Yeah. Hi, my question is about Lumo. So with self-hosted ClojureScript now, do you foresee any kind of incompatibilities arising between the JVM-based ClojureScript and Lumo? And or rather, could Lumo make it into the mainstream ClojureScript in future?
Okay, so there are two things to be said regarding your point. So the first one is there are obviously going to be incompatibilities just because of the fact that in regular JVM ClojureScript, macros are written in Clojure, right? So if you're writing a macro in Clojure and you're taking advantage of some JVM libraries, those are not going to work in self-hosted ClojureScript. The other thing is something that we kind of solved when doing